Good afternoon, everyone. Once again, I welcome you, all of you, on the third day of this 7 days workshop on time series analysis and forecasting using Excel. As you all know that the topic is linear regression in two variables and n variables. And on behalf of Inspira Research Association and CIMT Patna, I once again welcome Professor Brijesh Avasthi sir. If any query regarding the past two sessions, you can ask to Dr. Brijesh sir before starting today's session. So any query you can ask participants. Yes, Brijesh sir.
Thank you, Ravi sir.
Thank you.
Very good evening, everyone. Is there any doubt in yesterday topic? Please let me know. I think there is no doubt. Am I right or wrong? Okay, I got one response from the chat that there is no doubt. Wonderful. So I'm going to start today's session. Yesterday we talked about in beginning, that is what correlation. Then we started regression analysis, and in regression analysis we discussed the linearity of data, that is our data is linear or not, and how we can test that our data is linear. We have two techniques. Number one, with the help of graphical method we can find it out that there is a linearity or not, and the second one is what the correlation. With the help of correlation we can check that there is a linearity or not. If coefficient of correlation is high, that it shows linearity. If coefficient of correlation is low, that means it shows there is no linearity. And then we conduct a correlation test to confirm it, that is there is a linearity or not. Then we discuss about the regression equation, two variable regression, then multivariable regression. In case of a two variable regression, we use 2-3 methods. Number one is what graphical method. We just draw a scattered plot, and after drawing a scattered plot, we using the different layout number 9, we find the equation. Then second method was to find to use the functions of Excel, that is what intercept and slope. With the help of intercept and slope, we find the value of A and B in case of a two variable regression, right? And then if I'm talking about the next method for regression, that is what data analysis tool pack. Through data analysis tool pack, we find the coefficient of regression equation. Then we make a equation, right, in two variables as well as n variables. I'm going to share my screen so that it is visible to you all. I hope it is visible to you all. Now, again, I come back to this point. Suppose we have two variables, that is what promotional expenses and sales unit. And what I want to check, I want to make a regression equation with the help of data analysis tool pack. What you will do, just click on data, then data analysis, and you will use, that is regression. This is what regression, just click on OK. And after clicking OK, what you will do, you will select the input Y range. This is what my Y range, right? And this is what my X range. I haven't select the title, that is what label, I haven't select. Then I just click OK, right? When I will click OK, I will get the output of it. And I'm just going to analyze it in a brief manner so that you will able to understand. Just a minute, I'm going to set it. Okay. So if you will see the value of R, R is talking about the linearity. So value of R is 0.97. So definitely there is a linearity between the variables. If I'm talking about the value of R square is 0.95. That means 95% variation of dependent variable is explained by independent variable. So it's going to show you the goodness of fit test, right? Then we directly come to the coefficients, right? And if I'm talking about the coefficient, so coefficient is basically I have to write from here. Coefficient is basically what? That is y is equals to intercept value is minus 1.4857 plus the value of beta is what? 0.907, right? This is what this is intercept, which is in blue color. If I'm talking about in peach color, that is value of beta. So this is what plus 0.907 multiplied by x. X means your independent variable. So this is what a regression equation. Now there are few things which we have to discuss more. That is the significance value of ANOVA. If I'm talking about the value of significance of ANOVA, that is what F. What's the meaning of this? If you will see, the value of F is 0.000, right? The value of this is what? 000. Agreed. So it is less than 0.05. So there is a significant. This is what? Significant. What's the meaning of it? The meaning of it is what? The independent variable reliably predicted the dependent variable. Because of, in this case, we have two variables, dependent variable and independent variable. The significant value, that means in case of our analysis of variance, ANOVA, if the p value is less than 0.05, it shows that the independent variable is reliable, predict the dependent variable. That means the model is perfectly fit. Your independent variable is going to explain the dependent variable, right? So model is perfectly fit. But when it is less than 0.05. So this is very important part. If the value is more than, if this value is more than 0.05, what it shows? That is my null hypothesis is what? Correct. And what is my null hypothesis? That my independent variable is not reliably predict the dependent variable. Right. So in this case, my value is less than 0.05. It shows what? That my independent variable is reliably predict the dependent variable. Right. Now, the next point, which is important in this case, that is what? P-value. P-value of the independent variable. P-value of what? Independent variable. Here, P-value is what? Less than 0.05. Less than 0.05. When the p-value is less than 0.05, we are definitely going to reject our null hypothesis. And it's going to tell us that the independent variable, there is a significant effect of independent variable on dependent variable. I am just going to share my Word document with you. Just a minute, because of my writing pen is not working. I have to share it again. Just a moment. I have to save it then. No, it's not working. Just a minute. Now it's working. Okay. Right. So now just look at here. What we did, we have a case of what? This, where we have promotional expenses and sales unit. We have two things, that is what? Promotional expenses and sales unit. And we know it very well. If we are going to invest more amount on promotion, definitely we will get more sale, right? So it is in our mindset, that is what our sales is dependent variable, right? And promotional expenses is what? Independent variable. So I want to know the regression equation. That is what? Sales is equals to A plus B into promotional expenses. I want to know it. So with the help of regression method, we got it. That is what? We got Y is equals to, Y is what? Basically, Y is sales. Y is sales. So I just, Y is sales. So sales is equals to minus 1.4857 plus 0.97 of promotional expenses. Promotional expenses, right? If I'm going to put more amount on promotion, definitely I will get sale. What is the equation? This is the equation of it, right? But this model is correct or not, I want to check it. And it shows the linearity, and it shows the what? Best fit model. This is what? Best fit model. With the help of R square, we can check that our model is best fit or not. Now, if I'm talking about the significance level of analysis of variance, this is what? Anova. And with the help of analysis of variance, what exactly analysis of variance do? Can anybody tell me what's the meaning of analysis of variance? When we conduct analysis of variance test, anyone from you? Yes, please. Oh, I have to take some name. Yes, Nazim? Aditi? Shikha? Okay, let me know how many of you are present in the class. Raise your hand. Just raise your hand, please.
सर जब हमें सिग्निफिकेंट डिफरेंस देखना पड़ता है मीन
नहीं, अभी तो attendance. It is a time for attendance. It is a time for attendance only. So that I come to know कि कितने लोग class में present हैं and how many of you are attending class virtually. Virtually in the sense कि ठीक है, my laptop or my mobile phone is going to attend my class. Oh, right. Okay. I'm just asking कि when we will use analysis of variance, when we are going to compare the mean of more than two variables, compare more than two variables, then we will use analysis of variance. If we have two sample, we will use two sample. If we have one sample and I'm going to analyze one sample with some hypothetical value, that is what one sample test. If I want to compare two sample, we have two sample tests. When we have more than two sample means more than two variables, we will use analysis of variance to check that the average of all 3, 4, or 5 variables are same or not. Right. I'm just going to share my Word document with you so that I can write something on it. Because of these concepts are very important. I hope it is visible to you.
Yes, sir.
Right. Okay. just look at here. How many of you have Bonvita, Horlicks and Complan? बचपन में कभी पिया था, right? I want to know that my sample is same, almost the IQ level, height, class, demographic factor, except the parents, right? And the everything is same, and on a particular group, to a particular group, I am just giving what? Bonvita, right? And another group, I am going to give Horlicks, and other group I'm going to give Complan, and I want to check that all health drink are same or not on a particular criteria. It might be take a just like a height, right? So average increment in height of a candidate, average increment in a height of a candidates who are having Horlicks, average increment in a height, those person who are having Complan are same or not. So this is what my null hypothesis. That is, there is no significant difference between the means of our different group. There is no significant difference between mean of a different group. It is what my null hypothesis. In case of what? Anova. Right. So similarly, when I'm talking about a regression analysis, we have two things. That is what independent variable and another is dependent variable. And what I want to know that there is a significant difference or not. If there is no significant difference, that means this variable is going to very well explain the dependent variable. If I'll take one thing, that is what X, this is what Y, and this is what 1, 2, 3, 4, 10, 20, 30, 40. You will find a perfect correlation. Yes or no? There is a perfect correlation between X and Y?
Yes, sir.
Right. When there is a perfect correlation, can you say the average of X series and average of Y series are same?
Yes, sir.
Are you sure?
No, sir.
There is no average of X is what?
X is
2.5 now?
Yes, 2.5.
And average of Y?
20.5. 25.
25.
Right. So 22.5 is equals to 25?
No, sir.
No, na? So this is what? There is a significant difference between the groups, na? Group X
Yes,
and
sir.
group Y?
Yes, sir.
Though both the groups are having a relationship of 10 times more.
No, it
That
doesn't
is the
matter. It
same.
doesn't.
That is same.
I'm just taking this example that suppose we have two series X and series Y. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
And there is a relationship between this correlation is 1 na?
Yes, sir.
Yes, sir.
R is 1. And what about R square?
1.
There is
Also.
there is a linearity in the variables.
No.
Yes, sir. Yes, sir.
There is a linearity in variable. Clearly linearity in variable, right? Number 2, it is model fit or not? Best fit model or not?
Yes, sir.
Because of 100%
Yes, sir. 100%
variance.
correlative.
100% variance in independent variable is explained by independent variable. Yes or no?
Yes.
Right.
Yes,
So
sir.
this is also a
Yes,
perfect. This is also a perfect. We are doing fantastic. The next point is come that there is a significant difference between mean of X and mean of Y. Yes or no? There is
Yes, sir.
I want to check that there is a
Yes, sir.
significant difference between mean of X and mean of Y is yes or no?
Yes, sir.
Yes, sir.
Right. That
Right,
is
sir.
what in case of our analysis of variance, we reject the null hypothesis now.
Yes, sir.
Right. Now I'm just going to give you another example. Just look at here. This is what my X. 1, 2, 3, 4, 5. And this is what my Y. 1, 2, 3, 4, 5. Just tell me one thing. What is the value of R?
1.
1? Yes or no?
Yes.
Yes,
Yes,
sir.
sir.
What's the value of R square?
1.
1.
1.
1.
Okay.
Yes,
What
sir.
is the average of X series?
2.5. 2.5.
No, 3.
No, 3.
This time 3.
3. Yes, sir.
Yeah.
This time 3. Every time I will change the question. Right. And what is the average of Y series?
Same. 3.
3.
Again 3.
Yes, sir.
Again 3.
Yes.
Yes, sir.
Right. Both are same.
Yes, sir.
Yes, sir.
So what you will do? You will accept now.
Yes, sir.
So is this a model? You are going to develop a model that is y is equals to 0 plus 1x. Is this a model or not?
No, sir.
Because
No
of
model.
if you are going to develop a regression equation, now you will find this only. You can check if value of x is 1, then y is what?
Yes,
Yes,
1.
sir.
If x is 2, then y is
2.
if x is
2.
5, then y is
5.
5. So definitely we develop a model, but this model is not perfect. Why it's not perfect?
Why?
Because
Why?
of average of X series equals to average of
Why
Y
says?
series. Yes or no?
Yes, sir.
So it is required that when I'm talking about the analysis of variance, there must be a significance difference. The value of significance value must be less than 0.05. Yes or no?
But sir, null hypothesis is accepted in this model.
In this
Null
case, no.
there is
You just look
no
at it. What is the
significant
value
difference.
of P?
Value of P.
Yeah.
0. Near about 0.
0.0000.
Near about 0.
So this value is less than 0.05.
Yes, sir.
So what you will do? Null hypothesis is accept or reject.
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 Null hypothesis rejected. Yes or no?
Yes, sir. Yes,
And
sir.
what is our null hypothesis? That there is no significant
No
difference.
significant difference.
And if we are going to reject it, what's the meaning of it?
Except alternative
Null
hypothesis.
accept.
There
Alternate
is a
accepted.
significant difference between
Different.
mean of X series and Y series.
Yes, sir.
And it shows what? The independent variable reliably predict the dependent variable. The independent variable reliably predict dependent variable. Yes or no?
Yes, sir.
Yes, sir.
Right. So when you are going to develop a regression model, you have to check number 1 is what? Linearity. Yes or no?
Yes, sir.
Yes, sir.
Number 2,
Yes, sir.
R square.
Yes, sir.
Number 3, significance value of Anova.
Significance.
Right. Then next point is what? 4th point. That is what? The significance value of your this independent variable. The significance value of your independent variable. Yes or no?
Yes, sir.
Right. Okay. So in this case, our model is perfectly fit. Yes or no? Done. There are some more assumption also. I haven't discussed those assumptions. I will discuss after some time. But up to this point, my model is fit. Agreed? Now,
Yes, sir.
now you just come to the next case. If I'm talking about this case, can we find the regression equation?
Yes, sir.
And now this time you are going to predict it, right? I'm not going to help you out. Done? This
Yes,
time
sir.
you are going to predict the outcome. So this is what my Y series, this is what my Y series, and X all three are independent variables. And I have
Yes,
filled the label and just click OK. Now we got the output.
Oh,
Right.
Yes.
Just tell me one thing. Serial wise, in a sequence, you just explain that it is what exactly you think about it.
सर 99% एक्सप्लेन कर रहा है.
First of all, we will focus on what?
multiple, R multiple.
Linearity.
Linearity.
Yes, sir.
Next is what?
R square.
R square.
R square. Both are perfect now?
Yes, sir.
Yes.
Sir,
Okay. Now, in case of ANOVA, what's the value of P?
value of P. So there is a significant difference. Significant.
Yes, because of E minus 10 is there now.
Yes, sir.
So E minus 10 is almost, it is 0.00.
Yes, sir.
It is what? 0.00. Right.
0.0.
It is also perfect. That means my independent variables reliably predict the dependent, right? My independent variable reliably predict the dependent variable. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Next is what? Now I'm just talking about my regression equation. What is my regression equation? That is sales is equals to minus 44 point
0.70.
plus 1.477 into print media. Yes or no?
Yes,
Yes.
sir.
This is the value of A. And this is B1. This is B2 and this is B3. So plus
Sir,
1.
not visible.
My screen is not visible
Yes, sir.
Yes.
to all of you.
Yes.
Yes, sir.
Decrease.
No, sir, it's visible.
Just a minute.
Yes, sir. Right now visible.
Now it is visible.
Yes, sir.
Okay. So this is what my coefficient is minus 44.070, and I'll
Yes,
take
sir.
a 3 decimal. I'll take 3 decimal, right? For a convenience point of view. So this is what 0.071 plus 1.477 into 78 into multiply by print media plus 4.404
404.
of
40.
Social media.
Social media.
plus 11.454
454. Search engine media.
Multiply by search engine.
SEM,
Yes, sir.
right?
Yes.
So this is what my model. Now another important thing which we have to remember, that is what the p-value of my independent variable. What? The p-value, significance value of my independent variable. Can you tell me the significance value of my independent variable? What is the significance value of print media?
Significant value.
0.015.
0.015. This value is less than 0.05 now.
Yes,
Yes,
sir.
sir.
So it
Yes,
is
sir.
significance.
Yes, sir.
Yes, sir.
This
Significant.
basically, can we say now this value is what? Significance, yes or no?
Significant. Yes, sir.
And what about the next?
Same.
Significant.
All are
Same.
significant?
Yes, sir.
Right. What's the meaning of this significant? What's the meaning of this significant? Actually, when we talk about the regression analysis, we develop null hypothesis in regression. And what is null hypothesis? That there is
significant difference.
significance
Difference.
impact There
Impact
is no significant impact of
X and Y.
independent variable on dependent variable.
Okay.
Right. So in short, we can say that beta is equals to 0. What we can say? That beta is equals to 0.
0.
Yeah. Why I'm saying beta is equals to 0? You just look at here. Yes, everyone, please focus on the screen. I'm writing something that is y is equals to a plus v
Dx.
of x.
Yes,
Yes or no? This is my regression
sir.
equation.
Yes,
Right.
sir.
Yes, sir.
If I'll say that y is equals to 100.5 plus 0 multiply by x. If I'm going to increase the value of x or decrease the value of x, what is the impact on y?
There will be no change, sir.
There is no change. Why no change? Because of the
No significant
value
impact.
of beta is equals to 0. Yes or no?
Yes, sir.
So this is what? There is no significant effect or impact of independent variable on dependent variable.
Dependent variable.
I think it is clear now ki why beta is equals to 0.
Yes, sir.
Right. It is my null hypothesis. And what is my alternative hypothesis?
There
What
is a
is my
significant
alternative
different impact.
hypothesis? That
There is significant
there
impact.
is significant
Impact on independent variable
impact
and
of independent
Dependent
variable on
variable on dependent.
dependent variable. Yes or no?
yes, sir.
Yes.
And when you will get the impact, when you will see that there is an impact,
Y
suppose
equals
I
to
will say, suppose I am saying that y is equals to 100.5 plus 23.75 of x. Now, if I'm going to change in value of x, definitely your value of y will change now.
yes, sir.
Yes, sir.
Right. Okay. So there is an impact. Yes or no?
Yes, sir.
Impact. Okay. If I'll say that y is equals to 100.5 plus 0.0023 of x. Just tell me there is a significant impact of variable x on y.
No, sir.
Definitely there is an impact, but it is not statistically significant. Yes or no?
Yes, sir.
If I'm going to give the value of x is equals to 10, what is the value of y? Yes, anybody?
Near about 10. Yeah. Near about 100. Oh.
Yes or no?
Yes, sir.
5, then this 2, 3. Sorry, this just remove it. So 5 to 3. Yes or no?
Yes, sir.
So it is hardly, there is a very less change now, minimum change.
Yes, sir.
It is not significant. So we are interested to know that there is a significant impact or not. Agreed? And in our case, my all three variables are what?
Less than
Significant.
significant.
That means all three variables are very important, right?
Yes, sir.
Yes.
My all three variables are very important. Just a minute. Just hold on. I will open one more file. Is it visible?
Yes, sir.
Okay. Again, I'm going to find the regression of this data, which is with me. And let me check what exactly happened. Just I'm going to run, that is data analysis, regression. This is what my Y, and this is what my X. Done. And okay, I got it. It is the same. Okay, just leave it. Actually, I was thinking that I have changed some value in the data sheet, right? Okay, just leave it. Now, so what we learn, how we can check it that our values are significant or not. I'm going to run my another file, that is data for analysis. Now, I'm just thinking, it is my perception that weight is depend on height and IQ. Yes or no? It is my perception. So I want to make a regression model, that is what weight is equals to what? A plus B1 into IQ plus B2 into height.
Right.
Right? Can we find it?
Okay.
Let's see what happened. There is some problem with this. आज मेरी एक्सेल में कुछ ना कुछ प्रॉब्लम आ रही है, because of analysis tool pack is active, but it's not going to show in here, show at the data tab. Can you wait for 2 minutes? I will restart my system. Yes or no?
Okay, sir.
Yes, sir.
Just wait for 2 minutes, right? Just wait. Because of I'm not host right now. That is why I'm not able to share my screen.
Sir, now you can share, sir.
Thank you, sir. Now I'm going to again data analysis and regression, then okay, and my y is what? Weight. My y is what? Weight. And if I'm talking about the x, IQ and height is my x. And just click OK. I got the output. Now we are going to analyze it. Can you interpret this analysis? If I'm talking about the linearity, linearity is okay, right?
Yes, sir.
Yes,
Yes,
But what about the value of r square? Value of r square is not good,
47% only.
right? So it is not
Not good, not
goodness
significant.
of fit. It is not goodness of fit model, right? Then now I'm focusing on this significance value of ANOVA. It is less than 0.05.
Yes.
It is okay. That means the variable, overall variable are going to predict the dependent variable in well manner. Now just focus on the p-value of our independent variable. This value is what? More than 0.05. Yes or no?
yes, sir.
This is what? No significant. Yes or no?
Yes, sir.
Yes.
Here the value of IQ, the significance value of IQ is what? No significant. That means there is no significant impact of IQ on weight.
Wait.
Yes or no? So
Yes,
we
sir.
have
Yes,
to
sir.
remove it. It is not usable. I'm not going to use the
Yes,
IQ
sir.
in the model. So the moment you will find the value of P of your independent variable is no significant, you just removed it from the model. Agreed?
Yes, sir.
Okay.
Right. Now I'm going to repeat it again. I'm going to make new model. Yes, everyone? I'm going to make
Yes.
a new model.
Yes, sir.
This is what my Y. If I'm talking about the X series, I'll take only height. I'm not taking IQ. Just click OK. Now you just look at here and see the effect of model. Now the value of R is got, right? Correlation, that is what model fit is not good. This is good. And the p-value is significant. Yes or no?
Yes, sir.
The p-value is significant. So with the help of these process, we can check in a multiple regression that which variable is usable and what about those variable which is not usable. We can easily find it out. I hope it is clear to everyone.
Yes, sir.
Okay. Now I'm going to tell you what exactly the impact of R square. Why I'm saying it is a model fit. Are you interested to know about it?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
I will open new file so that I can explain it. It's not. Okay. So I will share my screen. It is visible?
Yes.
Yes,
Yes
sir.
or no? Right.
Yes.
Now I'm going to insert a column. I'm just going to give a serial number, right? Because of I need X now. Need X. So this is what 1 to 20. And I will take time and sales. There are two variables. And what I'll do, I'm going to create a scatter plot. This is what my scatter plot. What do you think? So there is a linear relationship or not between variables?
There is.
Yes, sir.
So linear relationship is there.
Yes,
And
sir.
I'm just going to find the regression equation. What is the regression equation? Can you tell me if it is visible to you?
Yes, sir.
If it is visible to you, just tell me the regression equation. What is the regression equation?
91.256x plus 314.76.
And what about the model fit requirement? That is what 0.974.
97% explained, sir.
Good, sir.
It's good. It is model fit, right? Okay. Now another. Again, I'm going to insert for time.
So how value of R square so that we can say that it is a good.
Yes, please.
So I just want to ask what should be the R square value so that we can say that it is a model of it.
Normally, what happens if your value of R square is 0.7 or more than 0.7. Sorry, R square value is more than 0.5. Then we can say it is quite okay.
Then it would be considered as a good.
Like you just look at here. You just look at here. Normally, what happens when value of R is equals to 0.7, we will consider that it is good, right?
Yes, sir.
When R square is what? 0.49. So we will not take 0.49, we can consider it 0.5. When R square, when the 50% or more than 50%, yes or no?
Okay, sir.
50% or more than 50% our variables are in our support, we will think that it's good.
Okay, sir.
So value of R square is more than 50%. And value of R is what? 0.7. right?
Yes, sir.
Okay.
Thank you, sir.
Now, just this is what time. I'm going to draw a scatter plot. And I'm going to find the regression equation. Yes, tell me what is the this is what linear relationship now?
Yes, sir.
Yes,
What is
sir.
the value of R square?
0.86.
0.86.
0.86.
Yes, sir.
0.86.
0.86. Agree?
Yes,
Yes,
sir.
sir.
Okay. I'm just going to double click on this regression line. Got it?
Yes, sir.
Yes, sir.
Now, the format trend line is appeared in right hand side.
Yes, sir.
Just click on this option. That is what trend line option. We have different trend line. On top, there is a exponential.
Yes, sir.
Please, you just note down the value of y is equals to 10840 of x minus 30660. That is the regression equation as well as R square. Please note down.
Done, sir. Done, sir.
Done.
Yes, sir.
Otherwise, you will say, no, sir, it is same. There is no change, right? Now, I'm just going to click. I'm just going to click on exponential. Can you see exponential?
Yes, sir.
Yes, sir.
I'm just going to click on it. Right? What is the value of R square?
0.98.
It is increased or not?
Yes, sir.
Increased. Yes, sir.
Yes, sir.
So which one is more fit? Straight line or exponential?
Exponential.
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 That
It's more
means
accurate, I
non-linear line is more fit as compared to linear. Agreed or not?
Yes, sir.
Yes.
If I'm talking about polynomial, what is the value of R square?
0.96.
Nice.
It reduced now, but
Near
it
about
is with
same.
order 2. But it is
Near
with
about
order 2. Order 2 means the value of x is raised to the power 2, x square and x. Yes or no?
Yes, sir.
If I'm going to increase the order, I'm going to increase the order up to 6. Up to 6. What is the value of R square?
0.99. Increase.
Increase 0.99. So which regression equation is more fit?
Polynomial.
Polynomial with order
6.
6. So can you see the power of Excel?
The power
Yes,
of
sir.
Excel.
itself.
Yes, sir.
See, earlier we were very much happy with the linear regression. Wow, we got a regression equation and we got the value of R square, which is going to indicate us the model fit, right? Goodness of model fit. But with the help of Excel, we can easily find out the model fit using exponential, linear, logarithmic, power, moving average. Yes or no? But with the help of moving average, we are not going to predict because of we are not getting any equation. We can get equation with the help of exponential. Can you see the what is the equation of exponential? Regression equation of exponential growth. That is y is equals to 11702 e raised to the power 0.1528x. Yes or no?
Yes, sir.
Yes, sir.
But what happened because of linear relationship is linear regression is easy as compared to exponential or polynomial. That is why the most of the researcher are using this method. It's a simple regression analysis, yes or no, or multiple regression analysis. Rarely researchers are using exponential, but it is very important. If you will see, suppose I'm not talking about the regression. If you will see the scattered plot, you can easily understand it is not a linear, there's no linear relationship between x and y, but actually there is a exponential relationship, yes or no? It is going to clearly indicating now that it is exponential.
Yes, sir.
sir. Yes, sir.
In fact, I am not going to draw properly, but it is very much clear. That is what it
It's
is.
okay, sir.
Exponential. Why? Okay, I am good in drawing. Deva. I
Okay.
draw fantastic exponential. Okay, so we
Very
can
nice.
easily find it out, right?
Right.
And again, if I'm talking about the relationship, again come back to this chart. This and chart design, layout, and regression. If I'll take the logarithmic, suppose I'm going to use logarithmic, and you will see, you just see what happened. What is the value of r square?
Sir, down
0.5.
59.
No, 5.59.
Going
Definitely
going
it is
down.
not logarithmic, yes or no?
Yes, sir.
It is either
Yes.
exponential or polynomial, or polynomial with the with what?
Order of 6.
5
6.
degree or 6 degree. There is a very less difference. If you will see order of 3, when order is 3, what is the value of r square?
0.98.
986.
Yes,
In
sir.
case of a 4,
So what exactly this
0.99.
order is showing?
what?
So what exactly this order is showing? I can't get it.
This order means, if you will see, when I'm going to use it, order 4, when I'm going to use order 4, can you see that there is x raised to power 4,
Yes, sir.
x raised to power 3, 2, and
Yes,
x? That means
Yes,
what is
sir.
the maximum power of x? 4,
4.
right? And when I'm talking about the order of 2, what is the maximum power of x?
2.
2.
2. If I'm talking about order of 6, what is the maximum power?
6.
Got it, my point?
Yes, sir.
Okay.
This is what
So
order.
that means this x is 6 times.
When
There
x
is
raised to the power, when in any of the equation, when x raised to the power 1 means this is called linear. When x raised to the power 2 or 3 or 4 or 5, right? This is what? Non-linear.
Non-linear.
Is going to show you non-linear. That means we are not going to draw a straight line. We are going to draw a curve according to our data. When I'm going to increase the power of x, it have more flexibility with the value of coefficient. You just look at what is the coefficient in this case. I'm just going to show you the coefficient. The coefficients are in points, yes or no?
Yes, sir.
Minus 0.062 x is to the power 6, 4.6 something. So this is what? to make a accuracy, to get the accuracy in linear curve or non-linear curve, we will use the polynomial, right?
Yes, sir.
I hope it is clear to everyone.
Yes, sir.
Wonderful. Now there's one more question to you all. Have you heard the term residual?
Yes, sir.
What exactly is residual?
Error.
Error.
Yes, sir.
And how we will calculate the error? I hope I explained this term yesterday, if I'm not wrong.
Yes, sir.
Yes, sir.
Okay, that is what you are going to tell me, or you have already idea about it?
Actually, tell me.
All right, just a minute.
Observed minus expected value.
Now I'm going to explain about residual. The average of residual must be what?
I think 0.
Zero.
Not why you are saying I think. It
Zero.
must be 0. Yes or no?
0. Yes, sir.
It must be 0.
Zero.
I will
Yes,
take this one. Please note down this equation. Done?
Yes, sir.
Okay. Now, just delete. What was the, it is what? Expected. What was the equation? What was the equation? I think you forgot. Huh? I have to do something. Control X. No, Control Z. Control C. Control V. Delete. I got the equation. I'll copy it. Control C. And I'm going to paste it here. Control V. And this is what my expected value. My expected value is what? Equals to 91.256 of X. Yes or no?
Yes, sir.
Yes, sir.
Plus 314.76. So this is what my expected value. And I'm going to calculate the expected value for all values. Right?
Yes, sir.
Now the difference between the
Actual minus expected.
actual and expected is what? Residual.
Residue.
So I'm just going to calculate it. So a residual is basically what? Equals to observed minus expected. This is what residual. Yes or no? And what I told you, that average
Yes.
of what?
Must be zero.
Average of residual must be
Zero. Zero.
approximately equals to 0, right?
Zero. Yes, sir.
So normally we will get very close to 0. Done, everyone?
Yes,
Yes.
sir.
Right. Now there is one more concept, that homoscedasticity or heteroscedasticity. What exactly is homoscedasticity or heteroscedasticity?
Homoscedasticity. Variance equal.
Likewise, unlikewise variables.
If I'm talking about homoscedasticity, what happened? The variance in residual, variance of residual must be equal. Yes or no?
Yes, sir. Yes.
Now, I'm just going to do the regression equation again. Just click on data, analysis, regression. This is what my Y series. And this is what my X series. And now you just look at here, everything is same. I'm just going to click on residual. Yes or no?
Yes, sir.
Sir.
I'm going to click residual plot. Right?
Yes, sir.
And just click OK. Can you see the value of residual? We got the same value now.
Yes, sir.
The first value is minus 156.014. Right? And what about in our case? Minus 156.016. Yes or no?
It is same, sir.
It is almost same.
Yes, sir.
This is
Exactly
what
same.
we can directly calculate the value of residual.
Yes, sir.
Right. And what about this? This is what a residual plot. Agreed?
Yes, sir.
Now I am interested to know that my data has homoscedasticity or not. And how we will check it?
No.
It is heteroscedastic.
Definitely. But we have to check it now.
Yes, sir.
So what we will do, I'll take another example. I'm just going to make this is what a residual square. Got it? I'm just going to calculate a square of residual so that I can eliminate the negative sign.
Yes.
Agreed or not?
Yes, sir.
So equals to this multiplied by this. This is what residual. Now I'm going to draw a scattered plot. Draw a scattered plot. Select data. Add X series. In X series, I'm going to take that is what? Predictive, right?
Sales.
Right. And in case of this, I'm going to take a square of residuals. Right. And just click OK and OK. Can you see the pattern of your graph? Residual. It is like this, yes or no?
Yes, sir.
This is what? It is not homoscedasticity. It is what? Heteroscedasticity. Yes or no?
Yes, sir.
That means the variation between the variables are increasing. Yes or no?
Yes, sir.
Yes, sir.
And what is homoscedasticity? If this graph is become like this,
Variance equal.
right? Like this. That is called variance between the X and Y is that is what error variance is what equal.
Equal.
But here the variance is going to increase.
Increase.
Graph might be like this. Sometimes graph is like this. Yes or no?
Yes, sir.
And in this case, this is what? Homoscedasticity. And this is what? Heteroscedasticity.
Heteroscedasticity.
Right. Now you just look at here. What I'm going to do. I'm going to test it again. Can I test? Okay, graphically we can understand. Can we test it again?
Yes, sir.
Yes, sir.
With new data.
One more doubt I have.
What is?
So earlier when we haven't squared the residuals. It means whatever the residuals we got earlier, minus 156.2.729.
Yes.
The chart of that residual and the chart of the squares of residuals. I think it is upside down.
No, earlier your chart were like this. Right? Because of positive values are here and negative values are here. If I'm talking about this value,
Yes, sir, yes, sir, got it.
it comes in negative part. Yes or no?
Yes,
This
sir.
time comes in what?
Positive
Positive
side.
part.
Yes, sir. Got it,
Yeah?
sir. Yes.
So test it again with new data.
You want to test it on the basis of new data, right?
Yes, yes, sir.
Okay. Can we use it?
Okay, sir.
First of all, what should we do? We should do that is data.
Yes, sir.
Then go to the data analysis, regression.
Yes, sir.
Yes or no?
Yes, sir.
This is your sales.
Yes.
And it is your independent variables.
Yes, sir.
Label, done, residual. I'm not going to draw a residual plot. Okay, I'll take residual plot. Right, residual plot.
Okay, sir.
And just click OK. You got 3 plots.
Yes, sir.
Right. And now this is what my observation, this is what my predicted sale, and this is what residual. What should we do?
Square the residual.
A square of residual, right?
Yes, sir.
A square of residual equals to this multiply by this. Got it?
Got it, sir.
Now what we have to do? We have to make a scatter plot.
Scatter plot.
Right. So just go to the insert, chart, scatter plot, then add data. X series is your what?
Predicted sales.
Predicted sale.
Yes, sir.
What about Y series?
Residual square.
Right.
Residual square. Okay, sir. Okay.
Can you see?
Yes, sir.
Now, in this case, can you see that what type of like it is homoscedasticity or heteroscedasticity?
Hetero.
It might be homoscedasticity. If we will eliminate this 3 points,
Yes, sir.
in that case, homoscedasticity, yes or no?
Yes.
Yes,
If
sir.
we will consider it, it become what? Heteroscedasticity.
Yes, sir.
That is why we have to conduct a test. Agreed?
Okay. Yes, sir.
Right. Now we will conduct a test. I'm just going to copy this, Control C, and come to the data. Alt Control V, that is what paste is special. I'm just going to take a values, right? I got the values. Yes or no?
Yes.
Again, I'm going to use regression. Remember this thing. Again, I'm going to use regression, but with what? Residual. Yes or no?
Yes, sir.
Yes, sir.
Data analysis, regression. Now, my Y is what? Y series is what? Residual.
Residual.
Agreed?
Yes, sir.
And my X series is same. My X series is same. That is what? Independent variable.
All
Agreed?
three or
All three.
okay.
Right. And again, just click OK. You got the output?
Yes, sir.
Now, the very important thing, what is the value of analysis of variance?
0.5.
0.5. That means you will reject your null hypothesis now.
Yes, sir.
You will reject your null hypothesis. What was your null hypothesis?
There is no significant difference between.
No, in case of this regression, that means the independent,
Expected sales and
yeah, key
predicted sales.
independent reliability predict the dependent variable. Your independent
Okay.
variable is not reliable to predict the dependent variable. Yes or no?
Yes, sir.
क्यों? क्योंकि यहाँ पर क्या है? We have a homoscedasticity. We are going to reject our null hypothesis, and our null hypothesis that our data has a homoscedasticity. But reality is this: our data doesn't have homoscedasticity. Agreed? Just tell me it is clear to you all or not. Okay, I'll take one more example. Can I take one more example?
Yes, sir.
Just a minute. Just tell me, are you enjoying or not?
Yes, sir.
No. Oh my God. Your answer is no, sir. We are not enjoying your session.
I say yes, sir.
Sir, today's session is very complicated.
Oh no, it is very simple. It is just like a halwa.
Sir, for
It's just
you.
like a halwa, but you
no-
have to give more attention. Do you have an idea about that? What we called? Where
But not
it
on
is?
your screen.
Where is my data? My data is missing.
So your screen is visible.
No, I won't share. In fact, I'm just searching.
Okay, sir.
You know, it is a matter of privacy, na? Am I right or wrong?
Right, sir.
That is why
Right.
I'm not sharing my screen. Right, I got it. Now I'm sharing my screen. It is visible.
Yes, sir.
There's
Yes.
another example which is related to advertisement. That is what I'm going to do: advertisement in TV, radio, and newspaper, and I want to see the impact on sales. Agreed?
Yes, sir.
And I want to check that there is homoscedasticity or heteroscedasticity is there. So what should we do first?
Data.
Regression?
Yes, sir. Calculate regression
Just
with
regression.
reducer.
Okay.
With
This is
reducer.
what my Y series.
Yes, sir.
And now I'm talking about my X series. That is what? My independent
Independent
variable.
variable.
And I want residual this time, right?
Yes, sir.
Click OK. Got it?
Got it, sir.
Now just look at here few points that and tell me it is perfect. The value of R,
Yes, sir.
Yes, sir.
value of R square is perfect,
Model fit, sir.
R square is good.
and the significance value is perfect.
Yes, sir.
And what about this significance value of for TV? Perfect.
Hmm.
Significance value for radio, perfect.
Yes, sir.
But significance value for newspaper is not good. Got it?
Got it, sir.
We are not going to use it, number one, in our regression equation. Now, if I'm talking about residual, what we have to do? Square of
Square.
residual?
Yes, sir.
Residual square?
Yes, sir. This multiply with this.
Right. Then what we have to do?
Graph.
Chart.
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 And predicted sale is your what?
X.
XE?
Yes, sir.
And residual is what your Y series?
Yes, sir.
Click OK.
Yes, sir.
Just tell me it is homoscedasticity or heteroscedasticity?
Homologous.
Homoscedasticity, yes or no?
Yeah. Yes, sir.
It is clearly visible. But because of we always believe on what? Statistics, na?
Yes, sir.
We don't believe in what? Graphical.
Yes, sir.
Right. So what I'll do, I'm going to select these three variables. Copy it. Come to here and paste as value. Done.
Yes, sir.
Now what next? What we have to do?
Regression.
Again regression?
Yes, sir.
What is our Y?
Cells.
Residual square. Yes or no?
Yes, sir.
Square of residual is our Y. What about our independent variable? Same?
TV, radio, newspaper.
Right. All are same. Just click
Yes, sir.
OK. Just click OK and just check the values. There is a problem, yes or no?
Yes, sir. So linear is problem and R square also.
Right. Now, what I'm going to do, because of in previous analysis, I got one thing that my newspaper is misbehaving. It's not supporting, right?
Okay.
Can I remove it?
Yes, sir.
Right. So I'm just going to remove it. So I have to do it again. I'm just
Okay.
going to delete these sheets, this, and I'm just going to delete it. And this is also delete.
Okay. And
And
newspaper also. Newspaper.
newspaper is not usable. I'm just going
Yes, sir. Deleted.
Done?
Okay, sir. Done, sir.
Okay. Again, come to data analysis, regression, This is your Y series. If I'm talking about
Two variables, TV and radio, independent variable.
right, and just click OK. Got it?
Yes, sir.
Just check all the values, please.
Yes, sir. It's good. Model fit and
Everything is perfect.
yes, sir. Perfect.
That is what value of R is perfect. R
Yes, sir.
square is perfect.
Yes, sir.
It is also significant. And the p value of radio and TV is perfect.
Yes, sir. Perfect.
Nothing is problem. Right.
Yes.
Now what we have to do?
Reducible square.
We
Reducible
have to
square.
calculate the square of
Reducible
it
square. Yes, sir.
equals to this raised to the power 2. Done?
Done, sir.
Right. Now what we have to do? We have to draw a scatter plot.
Yes.
If I'm talking about X series, the predicted sale is my X series.
Yes, sir.
And what about my Y series?
Reducible square.
This is what my Y. And OK. Now it's good.
Yes, sir.
Right. Now I'm going to again test it. Control C. Come here. Done?
Yes, sir.
Again regression. Which one is your Y?
Y is reducible square.
And what is your X? Same?
Same.
Now it goes down now.
Sir, can you paste in same sheet?
Yeah.
Because easy for comparison.
Earlier it was 0.16 now.
Sir, please paste in same sheet. At same sheet.
This is what sheet number 3.
Yes.
It is sheet number 4.
Yes, sir.
Right. Now significance value is what? Higher. That means there is no significant difference. Yes or no?
Yes, sir.
But we have to do it again. Further, I'm going to do it again. And what I'm going to do, you just look at here. I'm going to select the value of predicted value. Yes or no?
Yes, sir.
And control V, that is what paste. Then what I'm going to do is square of it. What I'm going to do is square of it. It is little bit complicated, huh? Equals to this cap 2, the square of this value. And now I'm going to do a regression. Again, I'm going to do a regression. Regression. This is what? Third time regression.
Yes, sir.
Right. And regression, what is my Y? Y is what my residual square.
Predicted delta.
Right. Y is my residual square. And
Okay.
my X, that is what? Independent variable is what? Predicted cell and predicted square. Got in my point?
Okay. Okay. Okay, sir. Yes, sir.
And just click OK. Can you see it?
Yes, sir. It's very
Here
less.
also, the value of significance is what? More than
Down.
0.05. You are going to accept the null hypothesis.
Yes, sir.
In previous sheet, this value is what? More than 0.05. You will accept the null hypothesis.
Yes, sir.
Right. Okay. And what is your null hypothesis in case of this sagacity test? What is your null hypothesis? Yes, come on, everyone.
Impact on independent variable and non-independent.
No. What we are doing?
So we are finding the how much residuals is moving according to the dependent and independent variable.
Our null hypothesis that our residual is what? Homoscedasticity. Yes or no?
Yes, sir.
Okay, sir.
And what we are going to do? We are going to accept it now.
Yes, sir.
Yes.
If I'm talking about previous sheet, this is also what? More than
Accept.
0.05.
Yes, sir. Accepted.
Accept it. If I'm
Yes,
talking
sir.
about my first regression, when I'm not talking about residual, my model is fit.
Yes, sir.
So this is a perfect model. Hamara perfect model kya bana? What is our final model? That is sales is equals to 2.92 plus 0.045 into TV plus 0.187 into radio. Got your point? This is what my final model. You got my point or not?
Yes, sir. Yes, sir. Got it.
If you have any doubt up to this point, please let me know. Please tell me.
सर प्रैक्टिस की रिक्वायरमेंट प्रैक्टिस
तो
करना
मैं
पड़ेगा
एक बार तो ट्राई करके
Okay. Practice की requirement है. There is a need of practice.
Yes,
Can I open one more data?
Okay, sir.
Yes.
Right. And can you check that there is a homoscedasticity or heteroscedasticity? Can you tell me?
Yes, sir, we can try.
Okay, you can try. Wonderful. Just a minute. I just remove it. Delete. Now, there is some problem with my system. Ravi sir, request to you, please. Yeah, thank you. Right. So, how will we proceed? Can you tell me?
So first of all, we calculate regression or reducible.
Linearity and R square.
Right. So you are going to instruct me that how we will proceed. So you are saying that I will explain what exactly it is. This is what mile is, right?
Yes, sir.
And the vehicle specification like horsepower, volume, weight, and gear and all. And I want to know ki, there is a significant impact of these variable on mileage or not. So I will write that this is what dependent variable and this is what independent variable 1 and independent variable 2, independent variable 3 and independent variable 4. There are total 4 independent variable and 1 dependent variable.
Yes.
So what should I do? I just click on data, data analysis, then regression and regression. This is what my dependent variable now?
Yes, sir.
Okay. Then
Independent variable.
independent variable,
Yes, sir.
done. Then label residual, okay.
Oh, okay, sir.
Now just tell me that this model is fit or not.
So model is fit.
Model is fit. How you will say?
Yes, sir.
Because
Sir,
of these two
multiple
variables
are.
are perfect.
Yes, sir. Perfect.
These two
Model fit.
values are perfect. This value is also significant.
Significant.
If I'm talking about the p-value, except one value, that is what?
3. IV3.
Rest of the variables are what? Significant.
Yes, sir.
And this time I'm just going to ignore it. Okay. And then what we
Can
will
we
do?
Then make this
did square?
Residual
Reduce-
square. Why we are going
reduce.
to calculate residual square? We
to
want to
eliminate
check
the minus
graphically
sign.
that there is a homoscedasticity or heteroscedasticity, right?
Yeah. Yes, sir.
So we got. Now I have to draw a chart. Yes or no?
Yes, sir. Reducible. Redressal. Okay. Predictive value.
Right. Okay.
Yes, sir.
And okay. What do you think about this chart?
It is a homoscedasticity.
Homoscedasticity. Yes or no?
Yes, sir.
Except
Yes, sir.
these 2 points. Rest of the points are perfect.
Yes, sir.
2 points are basically outliers. Yes or no?
Yes, sir.
Yes.
Just because of outlier, these are behaving like this. Okay, we just ignore it. Then what should we do? Can we check it statistically?
We
Yes,
have
sir.
to check.
Right. So we are
Cut
going to
past.
check it statistically.
And by calculating again the regression.
Right.
Yes, sir.
Then what should we do? What is next?
Calculate regression. Yes, sir. Data. And
Then residual
is value of y.
and variables are same.
Same.
Right. Okay. Just tell me about the interpretation of this.
So, sir, okay.
If I'm talking about this value, just focus on it.
Sir, leverage is good.
This value is what?
Significant.
Significant.
Significant. Significant means what? This value is less than 0.05. So what you will do?
Reject the null hypothesis.
Reject.
Yes or no? You will reject the
Null
null
hypothesis.
hypothesis. When you are going to reject the null hypothesis, what is your null hypothesis?
There is a
no
homoscedasticity between the data.
mileage and others.
That means null hypothesis what? That is homoscedasticity, and you are going to reject it. Though actually we have what? Heteroscedasticity. Yes or no?
Yes, sir.
Yes, sir.
And you can check it again also. And how you will check it again?
Square of redressal predict value and square of predict
I'm
value.
going to take predicted value
Square of
and I'm going to square of it.
predict value. Okay.
Square
Predict.
of predicted value equals to this raised to the power 2.
Yes, sir.
Then again regression.
Yes, sir.
Now this time independent variables are predicted.
Yes, sir.
Okay. What is the value of E? What is the value of significance?
5.27.
Less than 0.05 now.
Yes, sir.
Yes, sir. It is exponential of 0.9. Yes.
Null hypothesis.
Rejected.
Rejected.
Null hypothesis rejected. So it is what? This is a case of
Heteroscedasticity.
heteroscedasticity. Yes or no? And if it is a case of heteroscedasticity, we are not develop a model. Yes or no?
Yes, sir.
Yes, sir.
So if you will see in this case,
So what will be interpreted by you this?
actually what happened when we talk about the model, when we are talk about the model, there are so many concepts are working, right? If there is a change in variation with different values, for example, have you heard this term, your data must be normally distributed?
Yes, sir.
What's the meaning of this data is normally distributed?
But
Maximum data comes in a NPC graph.
Can you explain it with the help of correlation? Can you give me the example of correlation?
so there must be a
If
positive.
there is a linear correlation, sir.
I will explain you. Now you just look at here. This is what series X. Yes or no? This is
No,
series
sir.
Y.
Yes, sir.
And you can easily calculate that what kind of correlation you have. And we have what? Positive correlation. Yes or no?
Yes, sir.
Yes, sir.
Right. And definitely for many value of X, suppose value of X is 10. There are many different values of Y now.
Yes,
Yes,
sir.
sir.
Yes or no?
Yes,
So
sir.
if I'm talking about normal distribution, what? Normal distribution. This is what my x-axis and y-axis. And if it is my regression line, and if I'm talking about normality of data, what I'm talking about? Normality of data. My normality of data is look like this. Are you able to understand? That is what
Yes, sir. Yes.
if value of
Speaker.
x is 10, the value of y is might be 15, 16, 17, 18, and 19. But the maximum values are what? 17. Yes or no?
Yes, sir.
Maximum values are 17. There are few values which is what? 16 and 15. There are few values which is what? 18 and 19. This is called normality of your data. Right? If there is a point like this, just tell me your data is normally distributed or not.
It is not, sir.
No, sir.
In this case, it
Skewed.
is not, which is in red color. Yes or no?
Yes, sir.
So we are not able to, this regression line is not perfect because of your data is not normally distributed. If your data is like this, in that case, your data is normally distributed. Your regression model is perfect. Because of the mean value, the most of the values are on your regression line. The most of the values are on your regression line. When the most of the values are on your regression line, definitely the variance is also lesser now.
Yes, sir.
Yes, sir.
When variance is lesser, that means the variance of when value of x is 10, the variance is say 2.5. Yes or no? When the value of x is 20, the variance is also 2.5 or 2.6. So in this case, the variance at different point of x are almost same now.
Okay,
So
sir.
the variance of x, y is increasing in the same direction and the
No.
same.
No. You just again come back on the Word document. Suppose I'm talking about this point of this place. Yes or no?
Yes, sir.
When value of x is what?
10.
10.
Value of x is 10. Value of y is 15, 17, 18, 15, 15, 17, 17, 18, 17, 18, 19, like this. Can you
Yes, sir.
calculate the variance of these values?
Yes, sir.
Simple. It is simple calculation now.
Yes, sir.
You can use this function equals to var dot p. Yes or no?
Yes, sir.
Okay.
Suppose your variance is 1.65. Suppose, for example,
Yes, sir.
again, I will take the value of x is 15, 15, 15, 15. Your value of y might be आज मेरे इसके साथ में there's some problem with the MS Office. हेल्थ मेरी डाउन है, प्रॉब्लम कौन कर रहा है? एक्सेल, वर्ड.
Both are positively correlated.
Yeah, there is a correlation between me and my MS Office.
Yes, sir.
Positive correlation, sir.
Positive correlation. Oh. Insert. Right. Okay. Now just look at here. If I'm talking about this point of x, yes or no? When value of x is
Yes, sir.
10.
Yes, sir.
Agreed?
Hmm.
Yes.
definitely there are different values of y,
Yes, sir.
right? And I just calculate the variance of
Why?
y when the x is 10. Yes or no?
Yes.
Then again, I just calculate the variance of y when
When the
value
value
of
of
x is
x.
15.
Yes.
Suppose the variance of y when x is 10 is 2.5. For example,
Yeah. Yes. Sir.
variance of y when x is 15 is say 2.46.
Okay.
Variance of y when x is 20 is 2.25. Just tell me, is there any significant difference between these variance?
Yes, sir.
That is, I am
No.
talking about the fluctuations.
No,
There is,
sir. No.
there is no significant difference now, almost same.
Yes, sir.
But they are
Right.
reducing, sir.
Oh, oh my God.
Example, just this
You are
example.
so intelligent. You are so intelligent. I am more intelligent. Now 2.499. Got it?
Yes, sir.
So in this case, there is no significant difference now.
Yes, sir.
Yes, sir.
So it's going to show if you will calculate the residual now. So this is what residual when x is 10. This is the residual when x is 15. This is the residual when x is 20. The residual is same now.
Yes, sir.
Yes.
Near about same. Yes, sir.
The error is same.
Yes, sir.
This is called homoscedasticity. Got it my point?
Yes.
When homoscedasticity is there, your model is perfect.
Yes, sir.
If you have remembered, which I told you on day one, when you develop a model, I think day one or day two, I don't have remember. When you develop a model,
Yes,
the
sir.
expert will see your analysis and directly say your model is not good.
Yes.
How they will say? Because of there are so many different criteria. And you have to check all the criteria. When all the criteria are perfect, then only you will say your model is fit. Got it my point?
Yes, sir.
Yes, sir.
Abhi, there are two more things which are left. That is what number one is autocorrelation. Have you heard this term?
No. Sir.
No, sir.
And number two is multicollinearity.
Yes, sir. Heard somewhere.
Right. So tomorrow I'm going to discuss these two concepts. After discussing these two concepts, your regression is over. Then your regression is over. Madhav, you just think about it. After spending almost 8 hours, yes, 6 hours plus 2, 8 hours. I'm talking about tomorrow. After spending 8 hours, then you are aware with the regression. What exactly is a regression equation? It might be a
Okay, sir.
simple, it might be a multiple regression. Yes or no?
Yes, sir.
Any
Yes,
doubt? Any doubt?
No, sir.
Ravi sir, today's attendance, that means 10 persons are down.
Yes, sir. Because I think yesterday was 32 participants was present.
And today is 22.
Today is 22.
What's the reason behind it? Can we
I
analyze it?
think first the session is going to be more complex.
No, actually, I think, sir, I have shared the recorded videos of previous
It might be it might be a reason. It might be a reason.
But now I will not share the videos. I will share the videos after the workshop.
Yes, sir.
If I request you all to please attend this workshop, because I will not share the
Because of in YouTube videos, you are not supposed to do queries now. If you have any doubt, to whom you will ask?
Yeah, but I will not. I will not share now. I will share at the end of the workshop. So
Yes,
any question? you want to ask to Brijesh sir?
No, sir. Thank you.
Thank you. Yes, Aarti ma'am.
I have asked already.
Yes, sir. All the participants were very, very active and they were taking active participation. They were very zealful, very enthusiastic. So once again, thank you so much, Professor Brajesh Avasti, sir.
Thank you,
And
ma'am.
it was the end of the third day of this workshop come FDP on time series analysis. And the topic Am I audible, sir?
Yes, yes, ma'am.
Okay. So linear regression in 2 and n variables, OLS estimation. So as always, Professor Brijesh Avasti was totally awesome. He was so amazing today, although he was not well, but then also he there is some network error. So, sorry, today there is some network error. So, Sir Brajesh, sir, even when he was not well, but then also he took 2 hours to explain the concept so beautifully to the students. Thank you so much, sir, for being here and waiting for tomorrow's session.
Thank you, ma'am. Thanks a lot.
Thank you so
so
much,
much.
sir.
And please take care of your health,
Yes, yes, sir. Please take
Definitely,
care
sir.
of your health, sir, because because we will wait.
Now I am feeling very much pain in my throat.
Oh, so
Also
please take care because
take the medicines and or either
Definitely,
you
sir.
can go to RS club also.
Definitely, sir.
But this weather is also little it is mid of cold and hot weather, so this is also hurting probably. Please take care of yourself.
Yeah, ma'am. Thank
Yes,
you
sir,
very
take
much.
care.
Thanks a lot.
And thank you, Dr. Aarti ma'am, and
Thank
thanks to
you.
all the participants. So we will meet tomorrow at the same time on the 4th day on the session on the topic probability models for time series. So thank you so much.